Hey everyone. In this presentation, I'll go through some notes from Chapter 2 of book Designing Data-Intensive Applications. Chapter 2 is called Data Models and Query Languages. Here is a beautiful image from Chapter 2. Let's dive in. Let's look at some of the definitions from Chapter 2. So one is relational model. The best known data model today is probably that of SQL, based on the relational model proposed by Edgar Codd in 1970. Data is organized into relations, also called tables in SQL, where each relation is an unordered collection of tuples, that is rows in SQL. The relational model was a theoretical proposal, and many people at the time doubted whether it could be implemented efficiently. However, by the mid-1980s, relational database management systems and SQL had become the tools of choice for most people who needed to store and query data with some kind of regular structure. The dominance of relational databases has lasted around 25 to 30 years, which is an eternity in computing history. The birth of NoSQL. There are several driving forces behind adoption of NoSQL databases, including a need for greater scalability than relational databases can easily achieve, including very large datasets or very high write throughput. A widespread preference for free and open source software over commercial database products. Specialized query operations that are not well supported by the relational model, frustration with the restrictiveness of relational schemas, and the desire for a more dynamic and expressive data model. The network model. The network model was standardized by a committee called Conference on Data Systems, Languages, or CODASIL in short, and implemented by several different database vendors. It is also known as CODASIL model. The CODASIL model was a generalization of the hierarchical model. In the tree structure of the hierarchical model, every record has exactly one parent. In the network model, a record could have multiple parents. Now, relational versus document database today. There are many differences to consider when comparing relational databases to document databases, including their fault tolerance properties and handling of concurrency. The main arguments in favor of document data model are schema flexibility, better performance due to locality, and that for some applications it is closer to data structures used by the applications. The relational model counters by providing better support for joins, many-to-one and many-to-many relationships. Which data model leads to simpler application code, you ask? If the data in your application has a document-like structure, that is a tree of one-to-many relationships, where typically the entire tree is loaded at once, then it's probably a good idea to use a document model. The relation technique of shredding, that is splitting a document-like structure into multiple tables, can lead to cumbersome schemas and unnecessarily complicated application code. Schema flexibility in the document model. Most document databases and the JSON support in relational databases do not force any schema on the data in documents. XML support in relational databases usually comes with optional schema validation. No schema means that arbitrary keys and values can be added to the document, and when reading clients have no guarantees as to what fields the document may contain. Document databases are sometimes called schemaless, but that's misleading, as the code that reads the data usually assumes some kind of structure. There's an implicit schema, but it's not enforced by the database. A more accurate term is schema on write. That is, the structure of the data is implicit and only interpreted when the data is read. In contrast with schema on write, the traditional approach of relational databases where the schema is explicit and the database ensures that all rated data conforms to it. Schema on read is similar to dynamic type checking in programming languages, whereas schema on write is similar to static, that is compile time type checking. Just as the advocates of static and dynamic type checking have big debates about the relative merits, enforcement of schemas in database is a contentious topic, and in general, there's no right or wrong answer. Let's look at MapReduce querying. MapReduce is a programming model for processing large amounts of data in bulk across many machines, popularized by Google. A limited form of MapReduce is supported by some NoSQL data stores, including MongoDB, CouchDB, and a mechanism for performing read-only queries across many documents. MapReduce is neither a declarative query language nor a fully imperative query API, but somewhere in between. The query of the language is expressed with snippets of code, which are called repeatedly by the processing framework. It is based on the map, also known as collect, and reduce, also known as fold or inject functions that exist in many functional programming languages. Graph-like data models. Many-to-many relationships are an important distinguishing feature between different data models. If your application has mostly one-to-many relationship, like tree structure data, or no relationships between records, the document model is appropriate. But if many-to-many relationships are very common in your data, the relation model can handle simple cases of many-to-many relationships. But as the connections within your data become more complex, it becomes more natural to start modeling your data as a graph. A graph consists of two kinds of objects: vertices, also known as nodes or entities, and edges, also known as relationships or arcs. Many kinds of data can be modeled as a graph. Typical examples include social graph. Vertices are people, and edges indicate the people know each other. Web graph. Vertices are web pages, and edges indicate HTML links to other pages. Rail or road networks. Vertices are junctions, and edges represent road or railway lines between them. Well-known algorithms can operate on these graphs. For example, car navigation systems search for the shortest path between 2 points in a road network, or PageRank can be used on the web graph to determine the popularity of a web page and thus its ranking in the search results. To summarize, historically data started out being represented as one big tree, that is the hierarchical model, but that wasn't good for representing many-to-many relationships. So the relation model was invented to solve the problem. More recently, developers found that some applications don't fit very well in the relation model either. New non-relational NoSQL data stores have diverged into two main directions. One, document databases target use cases where data comes in self-contained documents and the relationship between one document and another are rare. Second is graph databases go in the opposite direction, targeting use cases where anything is potentially related to everything. All three models, that is document, relational, and graph, are widely used today, and each is good in its own respective domain. One model can be emulated in terms of another model. For example, graph data can be represented in a relational database, but the result is often awkward. That's why we have different systems for different purposes, not a single one-size-fits-all solution. One thing that document and graph databases have in common is that they typically don't enforce a schema for the data they store, which can make it easier to adapt applications to changing requirements. However, your application most likely still assumes the data has a certain structure. It's just a question of whether the schema is explicit, that is enforced on write, or implicit, that is handled on read. Each data model comes with its own query language or framework, and we discussed several examples like SQL, MapReduce, MongoDB's aggregation pipeline, Cypher, Spark SQL, Datalog. Book also touched on CSS and XSL XPath, which aren't database query languages but have interesting parallels. So this concludes Chapter 2 notes. Hope this was useful. Have a nice time. Like and subscribe for more such content.